you, Snowplow. Now, as I introduce our next speaker, I have to let you know that I am wearing special socks for this session, and I have been wearing them all day.
Wow.
They're Dremio socks that I received a couple months back, and our speaker is from Dremio. So Deepankar Mazumdar is currently a developer advocate at Dremio, where his primary focus is advocating data engineers, analysts, scientists on Dremio's Lakehouse platform and various Apache Foundation open source projects such as Iceberg, which we heard about in an earlier session, and Arrow, and that helps data teams apply and scale analytics. Dremio is the easy and open data lakehouse platform, a lakehouse platform for teams that know and love SQL. And today, Deepankar is talking to us about the Apache Iceberg, an architectural look under the covers. I'll briefly show the socks because I know some people won't believe it. I don't know if you could see that, but we've got Dremio right there. All right, without further ado, I'm going to go ahead and bring Deepankar on stage. Hello.
Hey,
Hi, Keith. Hi,
Deepankar.
Rohit. Hi.
How's it
Hi,
going?
Deepak.
Welcome to the Modern Data Fest.
Thank you. Thank you. Yeah, it's going good. I'm joining from Toronto in Canada, so yeah, it's a good day. Yeah.
Okay, awesome.
Amazing.
Well, we won't take up much of your time here. You've got about 10 minutes. We'll join you after that for some questions from the live audience.
Sure. I hope you can see my screen, right?
Yes, I'll share your screen.
Perfect. All right. All right. So yeah, today we're going to talk about Apache Iceberg and in general how it opens up the avenue for open lakehouse architecture. A brief introduction about me. I currently work as a developer advocate at Dremio. In the past, I have been involved with data architecture, machine learning, data visualizations. I also focus a lot about the community. Like I'm very much involved with the open source community and Apache Foundation projects like Iceberg and Arrow. You can find me on LinkedIn. I kind of post every single day and Twitter as well. So that's pretty much about me. So since we are doing kind of a lightning talks on the key talkaways, we kind of have from this session is that we're going to talk about the open lakehouse architecture. We're going to see how Iceberg fits in that and how it enables an open platform for different customers or vendors, and then a little intro about Dremio's lakehouse platform. So the evolution of the data architecture, right? Just to touch upon a bit, over the years, organizations have been really investing heavily on building centralized, reliable, and scalable data platform. The whole idea was that if they could democratize data, it would allow all sort of consumers like analysts and data scientists to leverage it and do all sort of BI and machine learning on all of the data. So data warehouse were kind of the first one that enabled to deal with the structured data, which allowed to do analytics such as BI, right? But then they lacked abilities to do deal with unstructured data, for advanced use cases like machine learning. So then came the era of the data lakes with the Hadoop ecosystem in general, with HDFS and Hive and everything. And data lakes were great. Like, organization could basically dump all of their data, whether it's unstructured or structured, semi-structured, in the data lake, whether it's on-premise, and now with the cloud storage like Amazon S3 and ADLS and Google Cloud Platform. But the problem is you can't just dump all of the data, and let the analyst and scientist, deal with the physically stored data, right? You want to be able to, let people use it for reporting or machine learning. And so you still need some way to organize the data and get it out in a structured way to a data warehouse. And then you could probably do your reporting. So ultimately with the data lake architecture, what we saw is that if you still have to do a BI, you still have to get it out of the data lake because it's unmanageable and you need it in a structured form. So you have the warehouse. And now we have the data lakehouse architecture, which I will come into the next few slides. But I'm pretty sure you can guess from the name what it is. And we heard from Tom as well. So going back to the main problem that you just can't dump all of the data in your data lake, right? You need some level of abstraction, right? You need some level of way to manage that data so that it kind of avoids from becoming a swamp, So Apache Hive was kind of the first one to do that sort of abstraction. So it became the de facto table standard for managing data files that landed in the Hadoop file system, right? So Hive was built by the data infrastructure team at Facebook, and basically they allowed the democratization of the big data, if you may. Analysts could basically use something called Hive SQL, right? You could query the data that you no longer needed to write any MapReduce job for that. So the abstraction complexity is what we are reducing here with HiveQL and something like that. However, Hive also brought in a lot of disadvantages. I'm not gonna look into them in details right now, but and on top of my mind, performance issues, multiple engines reading data from the same data set leads to some kind of issues. So those were kind of the major challenges that we saw with Hive ecosystem, right? Now, moving forward, these problems, what we saw is basically turned out that these problems were pretty much same in every organization doing large scale analytics, right? And like any bigger technological organization, Netflix were kind of the main one to like look at this problem, and they were like thinking that instead of putting band-aid to each and every problem, why don't we kind of take a step back and see the actual issue with what's happening, right? So one case study that I want to share quickly is from Netflix's system called Atlas. It's basically a time series system of Netflix's runtime metrics, right? And as you can see from the data here, in a month of data, they had basically 3 million files in close to 3,000 partitions, and that's a huge amount of data. So their problem was that they cannot process, more than a few days of data. For example, if you look at the query here in the right hand side, it's a pretty straightforward query, right? You're basically trying to get all the tags, based on a particular filter, which in this case is just a weeks of data from 22nd of August to 28th of August. So it's not even like a huge amount of data, but it's obviously it's Netflix, and we have a larger chunk of data that we're dealing with. With Hive, this particular query took just 10 minutes to just explain the query, not even execute the query, right? So just getting from the planning to executing the query and processing the data took the majority of amount of time. And this is where like Apache Iceberg comes into play, right? So what Iceberg essentially does, it's a table format to manage all the raw data files that are landing in your data lake. So like I said before, merely dumping data in your data lake would probably just lead to data lake becoming data swamps, right? So we want to be able to manage all the data and provide it to the analyst or the scientists who are going to use the data in an abstracted way, right? So Iceberg in a nutshell takes care of that. So it brings capabilities such as, you can basically use expressive SQL. You can query like all the files using SQL, which everyone loves. The queries are ACID compliant, which is very important when we're going to our data lake and lakehouse architecture, because we would expect things to be as it was in a warehouse, right? We would want the queries to be ACID compliant, to be reliable. If we have some new requirements coming in, like business requirements, they evolve quite fast. And, if you have a new column to add to the table or something changes in the schema, we want to be able to, add those quickly. And Iceberg allows you to do all sort of things, right? So you can query a bunch of Parquet file as a table using a simple SQL statement, as simple as that, what basically Iceberg facilitates, right? And it is also super fast, because it is designed to be like in that way, instead of like what the problem that basically Netflix saw with Hive, they basically dealt with the same problem and, said that, okay, why not, we just solve that problem by making it, at a file level rather than a directory level and make it super fast. So most importantly, what I kind of like about Iceberg and what kind of like opens up a lot of avenue is that Iceberg is open, which means the data is live openly in Iceberg. And, it's basically in an open ecosystem. It's not locked into a particular vendor, warehouse, or a system, right? So the best part about that is that multiple engines can work on the same data set at the same time. So for example, you can have like, you can use Apache Spark to do some processing. You can use Flink for streaming purposes or, something other for machine learning purposes, right? So Iceberg basically is the key technology piece that brings the best of the warehouse to a data lake for a data lake house architecture. So I would like to see Iceberg as the key technological component that enables that. So now I think we have a high level idea what lakehouse is, and we talked about it in general, that it's a combination of a data warehouse and a data lake. But again, it's just not just a mere integration of the two architectures, right? But kind of bringing the best out of the both worlds. So data warehouse has great data management features, but data lakes are also scalable and agile. And with cloud storage now that we see with Amazon S3 or like ADLS, they're extremely cheap. So why not leverage those abilities and scale your analytical capabilities, right? So if I have to visualize a lakehouse architecture, specifically the open lakehouse part is something that I am really, enthusiastic about, is because, like we said, the data is open. You're not locked into a particular vendor, and multiple engines can, use the same data at the same time. So it basically can look something like this, where you have, you can have a data lake, which is your cloud storage, and you can have multiple data coming in here, whether it's streaming data, batch data, and they can be in different file formats like Parquet or Avro or like JSON or CSV, right? And you can use a table format like Iceberg, and you can use that format to manage all those data files. So now you have all those abilities to manage those files, right? In a lakehouse architecture. And on top of that, you can obviously run any type of engine, like whether it's Dremio for like low latency SQL or batch SQL, ad hoc SQL, or whether it's Flink for streaming purposes, right? And on top of that, you can have all sort of app like Jupyter, whether it's a data science based app where Jupyter using Jupyter to access the data, or you're using Tableau or like Looker or that kind of BI tools to access the data, which is open. So what problem is Dremio solving here? The problem with the lakehouse, or in general, the main friction with the data lakehouse architecture is that there is a friction to get started with it, right? So that's where the Dremio's lakehouse platform comes and makes everything super easy, right? So you can practically have all the data in a cost-efficient data lake storage like S3. And what basically you can do is you can connect Dremio's UI to that particular data lake source and easily create Iceberg table on top of that data. So all this is basically using SQL, which everyone in data likes, loves. So you can use something like a create table statement and basically will allow create Iceberg table. Another important part of Dremio is that it allows you to natively connect to like the BI tools like Tableau or Power BI. And so what you can do is you can start building your dashboard directly on the Lakehouse platform. So you may ask the advantages, right? What is the advantage with that? So, well, for one, there is no ETL or like there is no need to move data from one system to another. So what we are kind of like, avoiding here, usually in the BI or ML world, how things work is that an analyst or a scientist, they would like the request the data to be, moved from whatever it's a lake or warehouse, and they have to wait on it for weeks, depending on the timelines of the data engineering team. And this process leads to multiple copies of data, until it reaches the point where the analysts or scientists have the data to be able to use it for, deriving insights. So why not be able to do that kind of, reporting or dashboarding on top of the data that's directly on the data lake using a lakehouse platform? So I'm going to end it here. I think one other important part was, just to touch upon was that what Iceberg is and isn't is that Iceberg is not a storage engine. It's not a execution engine of any sort, but it's more of a table format specification. It's a set of libraries and APIs that allows you to you can be any engine, whether it's Dremio or Spark or Flink, any kind of engine, and you can use it to leverage it for whatever purpose you want. So definitely, one of the main functionalities of Iceberg is that it's open, so it opens up the avenue for that. And yeah, I'm going to and take any questions that you might have. Thank you.
Awesome, Dipankar. That was a great session out there. I'm sure folks have learned a lot about Apache Iceberg today. I've learned a lot about it, and definitely will be taking questions. But
Sure.
I'll let my co-host ask the first question. Okay?
Yes, absolutely. First off, thank you so much. I definitely felt educated today because this is a pretty new topic for me. And in preparation for your talk, I did some research on the Iceberg, and I know you have something Dremio Arctic and Dremio Sonar. So maybe let's start with that. What's the difference between Arctic and Sonar? Is like one hot, one cold?
Yeah. So basically, the Dremio Lakehouse platform consists of Sonar and Arctic, and Sonar is kind of the main processing or the execution engine that allows you to process and deal with all sort of data, whether it's through Iceberg or any kind of data that's in a data lake, right? Mm-hmm. But then Arctic is kind of like allowing you to. It's kind of like the object store that kind of allows you to manage all the data in a more optimized way. And we're bringing in a lot of new features in a couple of months or in a couple of in the next few releases that will allow people to let optimally manage the data that's in Iceberg and that's in data lake. So that's going to be like the optimization and like the main store that's going to help and bring everything together for a lakehouse platform. So Sonar being the execution engine and Arctic being able to manage and meta store kind of.
Yeah, I think the one slide that really helped me understand how all this fits together was your data warehouse slide, how that feeds in with the data lake, which is more agile and scalable, and then that creates the data lake house. So I love that explanation.
Sure, that's it. And one question here, very interesting from Mike, which I wanted to pick. Mike Nash is asking, with Dremio approach, what are the key benefits for data engineering? Interesting.
Right. Yeah, very interesting question. And we are trying to hit that pain points, those pain points that we have seen with data engineering, right? So in general, like I said, with any kind of data engineering class, there has been a lot of requests for this multiple ETL pipelines that are going on that people, data engineering teams are flooded with those requests to move data and be able to provide that data to analysts. So with Dremio Lakehouse platform, it's basically the power is coming to it's a self-service platform, so it comes to the hand of the analysts or the consumers, right? And we are trying to avoid that, eradicate that pipeline thing, and say you have the ability to directly deal with the data that's on the data lake. So definitely a lot of burden on the data engineering side is reduced, but also we are also bringing in a lot of new features that kind of helps optimize those features for data engineering teams, and be able to focus on things that are important from a data engineering perspective, and let an analyst or consumer have that agility and that self-service ability to do all sort of analytics like BI and ML on top of the data, but not, that dependency from that data engineering team is kind of like shifting towards that.
Okay, very interesting. We've got another question here. It's around data governance and business rules. So maybe talk a little bit about how data governance plays in with Dremio.
Yeah, for sure. Yeah. So basically, a Dremio platform has different kind of so it's kind of have different kind of layers and governance capabilities. So Dremio has its own semantic layer capabilities, which allows you to basically define different types of rules and different types of permissions based on which particular team needs to have access to what kind of data. So definitely, governance is a huge aspect of when we're dealing with data, and that too, the data that is large scale and a huge amount of data in the data lake. So we have all the measures in place, all the RBAC policies or new governance policies that have been there, that has been implemented within the product itself. So everything is taken care within the same platform.
Okay, awesome. So, oh, sorry, Ravid, go ahead.
Yeah, I think this was pretty cool. Just one question that I had around, obviously, when I was looking into the Apache Iceberg, obviously, there was something where you spoke about hidden partitioning. So just wanted to know a little more about that as well.
Right. Yeah. And hidden partitioning is one of the one of the amazing part of the Apache Iceberg is that when in the in the previous era with Hadoop and Hive, right, we had basically in high table format, we basically had, for example, if you had to partitioning is a technique that allows people to deal with kind of a limited amount of data based on the partitions. So in the high table format, we had to go through and physically know the partition location for each of the individual analysts or consumer who is going to access the data. For example, if anything changes, for example, today I'm getting all the data by month, but then I want to change that data over with day, right? By day format. So I had to go and make all those changes and probably resetting all the data in the table. But with Iceberg, it kind of brings that functionality by default. So you have transformation abilities, and Iceberg knows intelligently. So you don't have to do those kind of physical partitioning. Users don't have to know that location of the physical location. So now that's one of the biggest features that Iceberg brings in.
Okay. By the way, I love how passionate you are about this. You're so excited to talk about Iceberg.
Yeah.
I love it. We've got a great question here from Brian on the Iceberg. Are you assuming that the data in the data lake is clean, curated data?
Yeah. So Iceberg basically, kind of brings that ability to do those integrated audits and make sure the data is of certain quality. So obviously, the problem that we saw in the previous architecture with data lake is that we are not sure whether analysts or scientists can use that data because it's a huge amount of data that's just lying there. Companies are dumping it, right? So with Iceberg, we are able to have those integrated audits. We are able to make sure that before we publish that data to production table, we are able to do those kind of audits and checks before that. So definitely, Iceberg brings those capabilities.
Okay, awesome.
Pretty
I think a good final question is that, I think people are still wanting to learn a bit more about this. So where can they go to continue their education on the topic?
Exactly. Yeah. And I was going to go back to that. So we at Dremio, we have a subsurface community where we do a lot of things on open source, specifically on Iceberg and Arrow. And, I myself and, a lot of my, colleagues contribute a lot to that subsurface community. And there are also these excellent blogs that are part of the Apache Iceberg official page. So, or the Apache Iceberg is something that, I can share in the slide as well. And I can, post out all the link. I personally post a lot on Iceberg every single day, almost on LinkedIn. So, that, I also make sure, I have the right balance of that. But I can share all the slide and information that I have, and, that would be great. Yeah.
Oh, see, I see Ravid shared the official page. Thank you, Ravid.
Perfect.
And
thank you,
for
Ravid.
the audience, make sure you're following the page and make sure you're following Dremio and Dipankar. And apparently he posts about this every single day. So now I'm going to see this in my feed because now I'm following you. I love it. Thank you so much for your time here today.
Thank you so much, Ravid. Appreciate it. Have a good one.
Thanks, Dipankar.
Awesome.
Bye.
Thank you.
Bye.
See you online.